Hello again, Internet. Today I'm going to make a box, and that box is going to hold these 40 pieces, which are calibration tools for my laser cutter. And some things of these are the same, so this distance across there, that's the same on all of them. Thickness is the same as well. They all have the same chamfer there, the same fillet there. The difference is the distance this way, and obviously the numbers printed on them. And right now I've got 40 of them, which I think covers me for everything. Um, so I'm going to make a box to store them all in, nice and neat and tidy. So I'm going to hide those. By the way, this is a copy of the part that has all those in there, so if I delete them or delete their bodies, it's not a big deal. So I'm just going to start with I was thinking on a Z0, but actually I think I want to start with the sketch on the side. Alright, so let's say that I'm going to make a box with that's 4 wide and 10 deep, because these are all in quarter-millimeter increments. So first row will be the 24s and the 25s and so on and so forth. So let's draw a profile, the tallest one in the first row. And that would be 24.75 millimeters. And I'm going to add 1 millimeter just so things aren't too tight. And then I need another rectangle for the second row. And put a dimension in here. Actually, I don't know what that dimension is going to be yet, because before that I need a different rectangle. Oh, a rectangle, not a line. And it's going to be right up against the back of this one. And I need a variable. So this is going to be equal to that material thickness. And let's see. Let's get rid of this horizontal. Say these are collinear and equal. And each row is going to be 1 millimeter higher than the previous one. So then this, we don't know how far away this needs to be from that yet. I'm going to select this chain, and I'm going to do a linear pattern with it. And let's see, there's 10 rows, so there's 9 dividers, but then there's a back piece as well. I'll just do 9 for this part of the process, though. So each block representation is going to be right up against the front side of the divider that it's up against. It won't be against the back side. So third block, fourth block, fifth block, 6, 7, 8, and 9, which means this does need to be 10. So that's my 10 rows. And let's go through here, get rid of the horizontals. And then I can go collinear and equal on all of those. And you know what? I went with this, but I want to add a millimeter safety margin there as well. So Each one is a millimeter higher than the previous one. All these one higher than the last. All right. These are just to help me see what I'm working on, so I want to just differentiate them. So I just stretch them out. I think that'll do the job. Just to have a little bit of control on them, though. Oh, I want that point there. I want it on the other one. Just for a little bit of control, I'm going to select this line and this point. Those midpoint, and then just put a dimension down here. Say 25. Well, they're not ridiculously big, but they're still big enough that I can see the difference. All right, so then out of the back one, we need to have our hinge, basically. So I prefer to use a M4 screw for these. So that's a 4mm nominal diameter as well. And new variable, a safe distance. I'll set that to 4 as well. Use that. And this will be tangent to back here. And let's see. Should also be another piece that's up front. I believe that would be right. Let's make those collinear and equal. And do a coincident there. And then just use this and this. Make these for construction and equal, just that the spacing is the same. And I need just a representation of where the break between the top of the box and the top of the box and the bottom of the box will be. So I'm just going to put in this horizontal line. And the hinge is going to be, or the center of the hinge is going to be right in the middle of that, of course. And then let's draw in a circle from there. Put a point on it. So this point will be touching the center of the box, and it'll be touching that. So basically, if it was like this and the lid opened right now, this point would follow along there. And I just need it to, I'm going to draw it as hitting that, but of course that's a millimeter out in both directions, so there'd be a little bit of clearance there. So I guess I bring it in and it'll slowly adjust for that. So the more I bring it in, the more it adjusts. I need to say, you know, I want a millimeter. I already have a millimeter there, don't I? Or millimeter spacing there, so less the better. You know, it's still got a millimeter of height, so a millimeter thickness isn't going to hurt as far as fitting. So then I can say that I want a millimeter front to back. And it'll basically say, okay, you can do that, but it's going to be like, let's see how far apart these are. The whole top of the thing is going to be 6.7 millimeters, which just my wood thickness is 4.5. So the pieces going into it would be incredibly thin. So that's not going to work. What if we just increase it a little bit at a time? I'll drop this dimension here, and yep, just make it driven. Go to 2. Try maybe 2.5 even. Slowly increasing. Let's see. And that would be barely acceptable, assuming I don't have a latcher handle. And as we expand it more and more, it has less and less effect. So even if I went to like 5, oh, 5. Yeah, that's about how far I'd have to go, and even then it's not even. So, how about we go the other way? How about, instead of having this as a driven dimension, how about we use it to drive? And let's say I want equals my wood thickness, or my material thickness, plus another material thickness, plus even just, I think, safe distance, 4, we'll call it 4. And how big is our gap this way? So our front to back gap there is 3.4, almost 3.5. So my material thickness plus my material thickness again. Let's get rid of this 4. Let's see what the gap is then. 1.7. So that's a lot more tolerable. The top's going to be on the thin side, but it'll work better that way. All right, so we've got all this that helps me figure out how this is actually going to be drawn, which is handy. So I'm going to get out of that sketch. And if I can move around without SolidWorks freaking out, let me put one block in space so that I can actually move around it. So let's go on this sketch and let's make a drawing of the cutouts I'm going to have. Adding +1 to both. Or, well, adding +1 to that way. This way, I can just use my previous sketch. All right. Select this chain, do a linear pattern. I want it to be 4 wide this way, and we'll just space it out. And then I want it to be 10 wide that way. Space it out as well. So then click here, it's pierce, and here it'll be wood thickness or material thickness. All right, so that's all the little opening holes, or however you want to call them, that I've got. So to that. And all right, that is how I want it. Let's sketch on, apparently on Y0 I'm working. And let's see, we're going to have pieces going front to back. And get rid of these horizontals on all but one of them. Make them collinear and equal. Just start dropping coincidence. Grab that. And these are all going to be the same length, so I might as well do that too. And just had a thought. I want to try something real quick. What if this distance, what if I brought it up to like maybe 8? It does shrink it down. So if I wanted this to be material thickness times 3, it really stretches it out. Put this as a meter of sorts. But let's say I add, let's see, if I go to 10, that's adding 4 in the back. It cuts it down a little bit, not as much as you'd like though. I want to go back to 4. Yeah, it's still only a part of a millimeter. Even at that. Alright. So let's cancel out of this sketch because I don't want to do what I was doing. Edit it again. Just this does need to be more now that I think about it. This needs to be at least material thickness times 3. So I'll delete the second one and just say it times 3. And that does mean that I've got 3.74 millimeters of gap front to back, which is a lot more than I'd like. But like I said, changing this up to 8, 4 only is 0.3. Oh, let's see, 0.3 times 10 is 3 millimeters. Whereas, so that's an extra 3 millimeters across the whole box. Whereas if I go up to 8, that's 4 on this side and 4 on this side. So that's an extra 8 millimeters. So 4 will do. Alright, just to double check. Say that I will go out to there. So up front, this can almost be touching and it's fine. In the back, it makes a big difference. All right. So I made a little bit of a change there, but it was necessary, I think. So we've got the bottom pieces, the bottom rails. Let's say this is equal to my material thickness, and I'm going to go the other way. And this way, I'm going to go up to this vertex here. And okay. I'm going to reuse this sketch. I'm going to start from this surface. And I'm going to go up to this vertex, and I don't want to merge. So those are the side rails that I've got. So 13.5. Oh. So yeah, that's just 3 material thicknesses. Which actually, come to think of it, we need to go the other way for 1 material thickness. Which means we only need 2 material thicknesses below the line. Which means our box gets a lot smaller. So, oh, this other way doesn't work because I'm going up to the point, and then I want to go beyond the point. So I'll just reuse the sketch to do it again. And I'll merge with those existing ones. Alright, so now I've got the rails, if you sides, however you want to call them, for the top and for the bottom. And I need to obviously do stuff to them still, but That's a start. So then I suppose I need the front up to there. And need to decide how I want the front to be laid out. Obviously, it'll be kind of like this. And I know this dimension is going to be equal to my material thickness. Or actually, it's not. Delete that. And just going to be coincident with that. And then I have to decide if I want these to slot into the front piece, which I think I do. In which case, go there and do the same thing on this one. So that's the basic shape of the front piece, which I want to extrude going this way equals my material thickness. I don't want to merge it. And we reuse that sketch on the other end. Use the same variable. And there we go. I need the same thing for the top, which is a little bit easier because I've already got all the work done. Just go like that. And go like that. And go up to this surface, but I don't want to merge you. And do the same thing on the back. All right. Just for the time being, let's get these out of my way. So I want a top and a bottom. Which are going to be, at least before engraving, they're going to be the same. Bring that out. And just give it a safe distance. And another safe distance. All right. And extrude downwards by my material thickness. And of course I don't want to merge it. And equals my material thickness. Don't want to merge it. Alright, so that's kind of the general look of the box. Still needs a lot of work, but kind of general, sort of, kind of, little bit look of the box. And I've got this sketch here. So we've got these pieces going all the way through. I suppose I could do like a piano hinge type deal. Only problem is that the openings are not multiples of my material thickness, but they could be. So what's my opening? So they're 20 wide. So like on the bottom end, it would be, whoop, bottom end about 4.3. Whereas at the top end, 4.6. 20 divided by 4.2 even. So either way, it's 5 times material thickness. It's interesting. I could make a piano hinge, and I like the idea of a piano hinge, so I'm going to make a piano hinge. Even if I have to make it a little bit wider, so be it. I want a piano hinge, and I'm getting a piano hinge. Let's see, which means this is going to be a little bit changed because these are going to have to come out. So let's say I sketch on here, and I want that. And I want to be able to see. Oh, but I didn't convert the inside. Convert it. There we go. Alright, so let's start from the bottom, I guess. As logical as starting from the top anyway. And go right to where it meets the wood, or meets the top. On the top one. And I suppose if we go equal, that's not ideal. That one has to be like that because of where it is, but the bottom one can be a little bit stronger. Let's make that for construction, and actually I'm going to make it perpendicular, and then tangent, and it didn't go for construction, I told it to. Come on, there we go. Alright, so that's basically going to be how the hinge has to come out. But what if it was a piano hinge that I could rest it on vertically? I'm already using the same amount of wood, so I might as well. So if I draw in that, go tangent, go coincident, and I'm going to say I want an arc like this that I'm also tangent with. That is going to be equal to this. Going to draw in a line. Say these are tangent. These are tangent when it lets me. These are parallel. And suppose these are equal. All right. We've got something going. So let's say I take this and this and this and this and convert those. Go up to here, and I want to trim this inside bit out, and I want that, and I think go up to surface like that, and I want to merge just with this. All right, just wondering how wide this is. 112. I've got threaded rod I can use, so that's no big deal. Then I need to figure out how the hinges are actually going to attach on the top. That's tricky too. Designing something new, you never know what you're going to run into. Alright, so let's say we take this and convert it. Take this and convert it. And we want that. And put it in a line there. So then just need to get rid of this bit. And we should be able to extrude with that. Alright. Then we need to figure out how it's actually going to connect into the rest of the part. And that's the tricky bit. So if it's 5, so bottom, top, bottom, top, bottom, top. There's 5 of those. maybe. Just to have that there. So then it'd be 2, and then 2 more. And then we'd be back to having that. Okay, so in between, these need to somehow be supported. And normally I'd have these as things that kind of slot into the back, but this back is so thin that that's really not an option. Which is a bit of an issue, because then how do I make them work? Let's see, if I made this back piece only come down more, then I'd have room to slot these into something. Yeah, this is only 9 millimeters. It's on the very small side. But if if just the back piece was smaller, then it'd be blocking it from rotating open. All right, I can't do that either. All right, I'm gonna pause, and I'm back. So I think I figured out how to get around the problem. What I'm gonna do is every other one I'll alternate. So start from this surface this time, go up to here, and merge with that, and do that one more time for the outside one. And I need to do the inside ones, which is just one more. All right, so that's really the only solution. I'm thinking putting some washers and stuff in between, maybe make it look a little bit nicer, but yeah, right now that's the only solution I could come up with. So at least for the time being, I'll call that tolerable. So we've got the hinge on the back. We've got got 2 back plates that we need to cut holes in as appropriate. Actually need to cut a lot of things. So let's see. Let's hide this and hide this. So we still need the dividers going this way. And to help with that, I'll bring the sketch back. And the sketch I can hide. Alright. And I think, yeah, it was working off Y0. And let's see, we're going to have a rectangle like that. It's going to be coincident with the outsides. It's going to be coincident with that and with that. And I'm going to select this chain so that I can do a linear pattern. And I probably should have put some distance in there so it's easy to work with, but whatever, it works. So that's all the dividers. And let me hide this to make the next step easier. So I'm going to go down to here. And I'm going to go up to there. I don't want to merge those. Then I'm going to reuse that sketch for another extrude boss. Starting from there, going up to there. Also don't merge. So now I've got a whole bunch of individual pieces, of course. That's fine. I can hide this sketch, get it out of my way. Hide this, let's see. That can stay, I think. So I want this piece to be held in by these pieces. So if I go like this, and I'm going to make this equals material thickness, and it's going to be the same distance the other way, so I can just do an equal. And then I can go coincident there. And I'll select this chain, do a pattern of 5. And go coincident there. Alright. Do an extruded cut that goes through all and only applies to the top pieces. And let's see, what else can we do here to these top pieces? Not even sure I should be working with this one, but whatever. Let's sketch here. Alright, so they've got an opening so that they sit on the non-openings there. So let's work on those just to match up what I just made. So these need to have a slot all the way from the top. Oh, not to the middle. All the way from the top to there. And that'll be material thickness. And I'll do a linear pattern of that. And I think I have 11 of these. Alright. And I've got this top side panel hidden. Need to unhide that. Go through all both and just select these side panels. Alright, so that looks like it's getting a lot more material, but it's actually going to be cut back quite a bit. Because the top is like to there, so if I draw in basically how these panels going forward and backwards are going to lock in, I'll basically have a tooth sticking up that's about that profile, give or take. And yeah, I'll just go ahead and draw those in. Actually, linear pattern them in, that's easier. And I know it's going to be material thickness tall. And I know the center point is going to be equally between these and these, so I can just draw a line from there to there, make it for construction and equal. So that locks it down in the center at least. And then if I put in a line, let's say this is going to be collinear equal, and for construction on both of those. So then if I say this to there, so construction line, and it's also equal. So then I just need to lock down the next 4, which actually means I only need to lock down 1. I'm going to drag it to about the right spot and make those equal. Alright, so that would be, those are the actual teeth. That's the part I want to keep. So I need to go like that, and like that, and just draw in basically the inverse real quick. It's easier to dimension to the actual thing you want to keep, so that's why I did it that way. And okay. So now those are all toothed, if you will. I'm gonna show everything and just hide the blocks because I don't need to see those. Alright, and I'll hide the top and the bottom. So I want to have that down here. So this time I can just draw in what I'm cutting away, because I can link it to what I did before. So let's say those are collinear and equal. And let me get rid of the vertical. Go ahead and get rid of a bunch of verticals real quick. Alright, collinear equal. Just go across doing that for all of them. Come on. Collinear equal. And collinear. Collinear equal again. And then one last collinear. And then I can do my cut. And I only want to do the bottom horizontal sides. Alright, so those are all lined up to go into the top and the bottom. So then what about the sides? Well, let's see. These are probably too big for, as far as teeth go. You want to get those smaller. So, say I draw, I'm starting with the second one just in case there's a slight difference. Patterning it this way is not a big deal. Patterning it that way, if there's a difference in the first one, would be a big deal. I think they're all the same, but makes no difference really, so I might as well do it this way. And say these teeth for construction equal, and I can just go a coincident there. Select chain, linear. Just in case there are differences on the end ones, which again I don't think there are, but just in case, I will just do 8 of these. And then I can do the end ones separately. And equal, and equal. And again, this is not what I'm cutting, but this it's easier to draw up what I want to keep and then adjust from there. Alright, so those are all laid out. Make those all for construction. And start drawing in what I actually want to cut away. And just keep going all the way down. Just constrain these last couple things, and we'll be set. All right. Now I can do a through all, and there. All right, so now I've got a whole bunch of approximately squares on the top there, and I got those. We don't have the teeth to match on the bottom though, so time to do those. So I'm going to draw just two for starters. Say that's collinear and equal and not vertical. And not vertical. So it could be collinear and equal. And not vertical. So that can be collinear. Select this chain, do a linear pattern. Start with 9. And just start with a big old space. And then we just need the last little bit. All right, use that to cut the bottom ones. Okay, so now the top and the bottom, everything is can be sunk into these plates. And this plate here, which we need to make those cuts, but we can worry about that after. So let's see. This face has cuts for those. This face does not have cut for those. And on this one, I just made it half the height, which was actually equal to material thickness also. But on this one, I'm also going to make it half the height. And let's go collinear and equal here. Get rid of the horizontal or the vertical, whatever it is. And do a coincident there. And a coincident there. Alright, so that'll cut the fronts. Select this chain, do a linear pattern of 8, I believe. Make that 9. And yeah, I'm not sure about that, the back part. Actually, I'm not even sure about the front part. I'll just cut these first. Alright, so now that side panel is cut at the bottom when I want it to be cut at the top. Great. Oh wait, I want the side panel to be solid on the top. So I did do that right. Okay. Then need to cut out of the cross panels. Alright. And that'll be coincident. So I want to cut out of the top of the cross panels. So grab that. And it'll be this wide also. And let's make a linear pattern of 5 of these. Just grab something to constrain it to. Alright, so now I can do an extrude cut through all. It's going to apply to all these cross panels, but not the front and back. I've got different plans for those, I think. Alright, so that only goes up to there, then this panel kind of holds it in place as do the others. And then need to figure out how this panel goes into this panel. On this one, it's just going in like that because we don't have room to do anything else unless we make this taller, which I'd prefer not to, because then it makes the whole box longer as well. But on the front, we can get away with doing something a little bit nicer, I think. So let's say, I'll sketch here. And let me hide this. So I'm thinking basically just use up like 1/3 of this whole front panel as a tooth. And it'll be going across as well. Yeah, that works. I'm going to select this chain, do a linear pattern of 5. And let's bring the front panel back. I can do a cut. Oh, there's something wrong with those, aren't there? So if I select that chain, it doesn't do it. Alright, that's odd. It's all for construction. And like that. Select chain. Okay, we're good. Coincident. And let's grab that front panel. Now let's do a cut. Alright. Go through the front. I don't even know what I'm going to do about the rear yet. Suppose I can go through it for now. And then I need to cut away the excess here. So I can go like that and like that. And apply it just to those. All right. So that locks in. That locks in well enough. Got to make the top and bottom holes, but that can come later. The pressing thing is figuring out the back. So right now it's not ideal. It's just not ideal at all. And I got to figure out a good way of actually dealing with this non-ideal situation. Because this panel, if we hide this, is just a solid piece right now, which we could punch holes in no problem. This panel's a solid piece too. Well, no, it's not. It's already cut out, so we're okay on that. And I already cut out those as well, didn't I? All right. I do wonder. Well, first I should have saved this a while ago. So. And let's check interferences. And this may take a minute. All right, so I'm gonna let this crunch away and think about that back panel and pause the video.